A dense metal projectile tears forward at an astonishing velocity of 3,950 feet every second. The location is Normandy during the summer invasion month of 1944. Inside his British Sherman Firefly armored vehicle, a tank commander observes through magnified viewing equipment as 5 German Panther combat machines advance steadily toward the defensive line near the village of Lingroves. The optical sights reveal frontal protection consisting of 80 millimeters of specially hardened battlefield steel that appears virtually impossible to defeat. Every conventional shell fired by Allied forces simply deflects away harmlessly like tiny stones bouncing off solid rock. However, the gunner named Harris possesses something far beyond ordinary ammunition in his arsenal today. The massive gun breech closes with metallic finality. The 17-pound cannon erupts violently backward from tremendous force. Within the forward German Panther, the crew members never perceive any warning of approaching danger. A narrow tungsten penetrator, no wider than a human forearm, has already punctured completely through their armored shell before the lightweight carrier components even strike the earth below. This incredibly dense core fragment explodes catastrophically within the confined crew space. Complete destruction achieved instantly. The turret rotates smoothly toward another target. Yet here exists the critical detail those German tankers fail to comprehend in these final moments of combat. This revolutionary capability stems not from possessing a larger weapon system, but rather from understanding precisely what occurs during the initial 30 feet following each firing sequence. A specially designed aluminum housing separates cleanly into 4 distinct sections that fall harmlessly aside, abandoning only the extraordinarily dense and impossibly swift core section that continues racing toward its intended destination. Pure physics transformed into absolute battlefield nightmare for the enemy. The second Panther erupts into violent flames. Then the third vehicle succumbs, followed immediately by the fourth and fifth tanks in rapid succession. 5 fired rounds equal 5 confirmed eliminations. Every engagement occurs at distances where the German Panther's own formidable weaponry should maintain complete tactical dominance over Allied equipment. The German Tiger I heavy tank had absolutely terrorized Allied armored crews continuously since its battlefield introduction during 1942. Its frontal protection, measuring 100 millimeters thick, simply laughed contemptuously at shells fired from 75 millimeter Sherman guns. The massive King Tiger variant mounted even thicker armor reaching 185 millimeters across its forward face. These were essentially mobile fortresses considered completely untouchable from direct frontal assault. German tank commanders like the legendary Michael Wittmann constructed incredible combat records with kill ratios exceeding 15 enemy vehicles destroyed for every single German loss, sometimes achieving even higher numbers, knowing full well that Allied tankers possessed absolutely no capability to penetrate their frontal protection during head-to-head engagements. Then Britain fielded ammunition technology that should have existed only in theoretical discussions, not through developing bigger guns or constructing heavier armored vehicles, but simply through one brilliantly elegant mechanical solution involving a disposable carrier that permitted a small yet incredibly hard projectile to fly faster than anything the German military forces had mathematically calculated as possible. German soldiers nicknamed them flaming onions after observing the carrier sections tumbling wildly through the air during flight. They should have focused their terror instead on what followed behind those spinning pieces. By early spring of 1943, British military intelligence analysts confronted a terrifying mathematical problem of strategic proportions. Aerial reconnaissance photographs taken over the Henschel production factory where Panzer vehicles were manufactured revealed Tiger I production numbers exceeding all previous intelligence projections by alarming margins. Not merely dozens of these feared machines rolling off assembly lines, but rather hundreds of them entering active service. Additional field reports arriving from the North African campaign theaters confirmed active development of the Panther tank. Described as a 45-ton medium-class vehicle featuring frontal armor sloped at 55 degrees, creating effective protection equivalent to 140 millimeters of vertical steel thickness. The industrial mathematics painted an absolutely terrifying picture for Allied military planners. Germany was dramatically outpacing Allied anti-tank capability development at an accelerating rate that threatened entire strategic operations. At the Lulworth firing range facilities located in Britain, military ordnance officers conducted absolutely brutal testing sequences against captured German armor samples. The standard 75mm gun, mounted in Sherman tanks, fired repeatedly at captured enemy steel from 500-yard distances. Every single round deflected harmlessly away without achieving penetration. The 6-pound anti-tank gun, representing Britain's primary infantry-level defensive weapon, scored direct impacts at 200 yards against Tiger frontal plating. Against that 100mm face-hardened steel barrier, exactly 0 penetrations occurred. Even at nearly point-blank engagement ranges, conventional ammunition types simply could not reliably defeat that thickness of specially treated steel protection. The strategic implications for planned invasion operations were absolutely existential in nature. Operation Overlord demanded landing 156,000 Allied soldiers onto heavily defended hostile beaches, then advancing rapidly inland through the dense hedgerow countryside of Normandy, which represented absolutely perfect terrain for armored ambush tactics. Intelligence estimates placed German armored reserve strength at approximately 1,400 tanks, positioned throughout occupied France, including multiple Tiger and Panther battalions held ready for counterattack operations. If British Sherman tanks fundamentally could not penetrate German heavy armor from frontal approaches, then every single engagement became asymmetric slaughter, heavily favoring the defender. Tank crews understood the grim mathematics perfectly well. A Tiger could reliably destroy any Sherman at ranges exceeding 2,000 yards. A Sherman needed to close the distance through completely open killing ground to approximately 200 yards distance just to possess any remote chance against Tiger frontal armor. The survival odds calculated out as absolutely catastrophic for Allied crews. However, projectile velocity offered one elegantly simple solution to this impossible problem. Traditional steel armor-piercing rounds shattered completely when impact velocities exceeded 850 meters per second. The crystalline material structure simply could not withstand impact stress occurring at those tremendous velocities without fracturing. Tungsten carbide, possessing twice the density of steel and far superior hardness, could survive impact velocities reaching 1,200 meters per second without fracturing into useless fragments. The problem remained that a full-diameter tungsten round would weigh far too much. Available propellant charges could never accelerate such tremendous mass to sufficient velocity within existing gun barrel lengths. The breakthrough solution emerged from two brilliant engineers working at the United Kingdom Armaments Research Department. Permutter and Coppock had dedicated their efforts since 1941 toward developing a conceptually straightforward yet revolutionary mechanism. Their idea involved wrapping a small tungsten penetrator inside a lightweight disposable carrier sleeve. This design would utilize the complete barrel diameter to maximize propellant gas pressure acting on the projectile assembly, then immediately discard the carrier wrapping the instant it cleared the muzzle opening. Simple physics principles applied with precision engineering would produce revolutionary battlefield consequences that would fundamentally alter armored warfare calculations. The workshop facilities at Woolwich Arsenal carried the distinct odors of metalworking cutting oil mixed with burnt propellant residue hanging heavy in the air. Engineer Permutter carefully examined yet another prototype design that had failed during testing trials. The aluminum carrier housing had separated prematurely while still inside the gun barrel. This represented catastrophic failure. The tungsten core tumbled wildly and unpredictably downrange after leaving the muzzle. Accuracy became completely worthless when projectiles flew erratically. Between the years 1941 and 1944, the Armaments Research Department consumed dozens upon dozens of experimental designs attempting to solve one fundamental engineering challenge. How could designers create a lightweight carrier that would properly transfer the rifling spin to an extremely dense core section, then separate cleanly without interfering negatively with projectile flight characteristics afterward? The answer existed in maintaining precision tolerances measured in tiny thousandths of an inch throughout manufacturing. The final armor-piercing discarding sabot design utilized a three-piece aluminum alloy carrier assembly. The forward section consisted of 4 petal-shaped segments covered with a nylon centering band for alignment. The rear section incorporated a rubber obturator seal and copper driving band for engaging barrel rifling. Total weight remained negligible compared to the dense core. The tungsten carbide penetrator sat nested inside, measuring 37 millimeters in diameter, designed for the 76.2 millimeter 17-pound cannon. Under extreme acceleration forces, physics principles took complete control. When propellant powder ignited, creating tremendous gas pressure, setback forces exceeded 100,000 times normal gravity. The lightweight carrier pressed firmly against the spiral rifling grooves, spinning the entire assembly as one unit. Simultaneously, an uneven base surface on the tungsten core section locked mechanically into the soft aluminum pot through pure friction forces generated by acceleration. The carrier successfully transferred rotational spin without requiring any permanent mechanical connection between components. Muzzle exit velocity measured 1,240 meters per second. Approximately 30 feet beyond the barrel opening, centrifugal rotational force tore the forward pedal sections loose from the assembly. Aerodynamic drag forces stripped away the remaining base pot section trailing behind. Total separation time required only 0.003 of 1 second to complete. What remained flying downrange was a solid tungsten dart spinning at 3,000 revolutions per second, maintaining tremendous velocity across 1,000-yard distances that would completely pulverize conventional steel projectiles through atmospheric friction heating and stress. Testing procedures revealed one critical design flaw requiring immediate correction. The 17-pounder's muzzle brake device, necessary for managing recoil forces, featured aperture openings too small for clean carrier separation. Sometimes, pedal sections struck the brake ports, deflecting the tungsten core off its intended target path. Accuracy performance dropped to only 60% beyond 500-yard engagement distances. The solution involved boring the aperture openings wider by just 2 millimeters. Teams of specialized engineers visited every single 17-pounder gun position throughout Britain during May of 1944, modifying muzzle brake assemblies using precision drilling equipment brought specifically for this urgent task. Factory-fresh guns received the critical modification immediately before shipping to combat units. By the scheduled D-Day invasion date, The weapon system was finally ready for battlefield deployment. The remaining question was whether sufficient ammunition quantities would reach Normandy forces in time to make tactical difference. The first armor-piercing discarding Sabot rounds finally reached British tank regiment units in late June 1944, approximately 3 weeks following the initial D-Day invasion landings. Most Firefly crews received exactly 6 specialized rounds per tank as initial allocation. Trooper McKillop, serving as gunner for Sergeant Harris's Firefly, had never previously seen ammunition resembling this unusual design. The projectile appeared visually wrong, with dimensions too small for the 76.2mm breech opening and wrapped in a bizarre aluminum jacket resembling a flower pot shape. The loader's instruction handbook provided explicit guidance: armor-piercing discarding sabot for use against heavy enemy armor only. Accuracy degrades significantly beyond 500-yard distances. June 14th near Lingroves became testing time under actual combat conditions. 5 Panther tanks advancing steadily through wheat fields. Range measured 800 meters. Harris's radio speaker crackled with transmission. All call signs: be advised, German armor moving north through sector. He did not wait for complete coordinates. Commands issued rapidly. Load armor-piercing, discarding sabot, target Panther at 800 meters. The sight picture through optics appeared perfect. McKillop squeezed the firing trigger smoothly. The gun erupted with violent flame. Muzzle blast so tremendously violent it ignited the hedgerow vegetation in front of their Sherman position. Through thick smoke and bright fire, Harris watched the devastating effect occur. The lead Panther's frontal armor, measuring 80 millimeters of sloped protection, opened like a thin tin can struck by hammer. Internal explosion followed immediately. The turret blew violently 15 feet off the hull structure. Crew members killed instantly by the tungsten core, fragmenting catastrophically inside the confined fighting compartment space. The remaining Panthers slewed sideways desperately, commanders screaming frantically into radio sets about some new British weapon achieving impossible penetration capability. Orders transmitted immediately to withdraw from engagement area. Already too late for escape. 5 rounds fired equal 5 confirmed kills achieved. Harris relocated his vehicle between each successive shot following tactical doctrine. The massive muzzle flash signature revealed Firefly positions instantly to enemy observers, making repositioning mandatory. But armor-piercing discarding sabot gave him what Sherman tankers had never possessed before this moment: the capability to engage German heavy armor frontally at realistic combat engagement ranges with lethal effectiveness. The psychological impact rippled powerfully through both armies simultaneously. British tank crews began actively hunting Tiger tanks instead of fleeing from encounters with them. German panzer commanders, accustomed to feeling invincible, now faced opponents who could kill them reliably at 1,000-yard distances, ranges where they had previously held absolute superiority over Allied equipment. After-action combat reports submitted from SS Panzer divisions noted with considerable alarm that British tanks equipped with unknown high-velocity ammunition were achieving frontal penetrations on Panther tanks, confirmed through physical examination. However, armor-piercing discarding sabot ammunition had significant operational limitations despite its revolutionary penetration capability. Beyond 500-yard distances, accuracy collapsed dramatically. The small tungsten penetrator, if it missed the target, kicked up almost no visible dirt spray, making it impossible to spot fall of shot and correct aim for follow-up rounds. Even worse, ammunition supplies remained critically limited throughout initial deployment. Most Fireflies carried only 5 to 6 armor-piercing discarding sabot rounds versus 70-plus conventional shells in their ammunition racks. Every single shot had to count because resupply was uncertain. By August of 1944, German armored warfare doctrine was rewriting itself through brutal battlefield experience paid in blood. Panzer Division intelligence officers compiled increasingly grim statistical data for analysis. Before June invasion operations, Tiger and Panther frontal penetrations achieved by Allied tank weapons measured virtually zero occurrences. After armor-piercing discarding Sabot introduction onto battlefields, 17 confirmed frontal kills occurred within just 3 weeks of combat operations. The fundamental mathematics of armored warfare had shifted dramatically and permanently. German military tactical manuals issued emergency revisions to all armored units. British Sherman variants armed with unknown heavy anti-tank gun capability. Frontal engagement not advised under any circumstances. Recommend flank attacks only as primary tactic. Not advised represented stunning language change. The Tiger, designed specifically and deliberately for frontal invincibility, now relegated to executing flanking maneuvers like lighter vehicles. British production capacity ramped up accordingly to meet urgent battlefield demand. Manufacturing facilities in Birmingham and Woolwich Arsenal increased armor-piercing discarding Sabot production from 2,000 rounds per month in June to 15,000 monthly by September 1944. However, tungsten carbide remained extremely scarce as raw material. Most supply sources came from Portuguese mining operations with severely limited output capacity. Every armor-piercing discarding Sabot round manufactured competed directly with tungsten needed for machine tool production, armor-piercing bomb construction, and numerous other critical war materials requiring this rare metal. Strategic allocation decisions followed brutal logic dictated by combat necessity. Priority 1 designation went to Sherman Fireflies, representing the only British tank mounting the 17-pounder gun system. By July 1944, approximately 2,100 Fireflies operated across Northwest European combat theaters. Standard ammunition load consisted of 6 armor-piercing discarding Sabot rounds plus 60 conventional armor-piercing ballistic cap rounds. Instructions remained absolutely clear. Armor-piercing discarding Sabot for Tigers and Panthers only. Everything else engage using conventional ammunition types to preserve precious specialized rounds. The Germans adapted tactical doctrine through accumulating casualties and hard lessons. SS Obersturmführer Michael Wittmann, the German military's most decorated tank commander with 138 confirmed vehicle kills, altered his tactical approaches completely. No more frontal assaults relying on armor superiority. No more depending on protection thickness to survive engagements. His tactical orders issued from late July emphasized concealment techniques, ambush execution from side angles providing vulnerable target aspects, and rapid displacement after firing to avoid counterfire. On August 8, 1944, Wittmann led 4 Tiger tanks against British positions near the town of Sintho in the Caen sector. He never saw the Firefly waiting in ambush. Trooper Joe Ekin, serving as gunner in Sergeant Gordon's tank, fired 3 armor-piercing discarding Sabot rounds at 1,200-yard distance. 3 Tigers destroyed in 90 seconds of devastating fire, including most historical sources conclude Wittmann's own command vehicle. The most feared Panzer ace of the entire Second World War, killed by ammunition technology that did not exist just 1 year earlier. German commanders noted the grim milestone with somber recognition. Their strategic advantage, built on technological superiority through heavier armor protection, had been effectively countered not through building bigger Allied tanks to match German designs, but through applying a simple mechanical principle involving separation of carrier from projectile after firing, Physics principles beat steel thickness advantages every single time when properly applied. August 8, 1944 at 1:47 in the afternoon, with temperature measuring 28 degrees Celsius. Trooper Ekins peers intently through his telescopic gun sight. The crosshairs dance across the wheat field vista. Heat shimmer distorts the air at 1,200-yard distance. Four shapes emerge from the tree-line boundary. Low-profile hull with angular turret design. Massive main gun. Tigers identified positively. His commander, Sergeant Gordon, keeps his voice deliberately calm over intercom. Armor-Piercing Discarding Sabot loaded and ready. Lead Tiger 1,200 yards. Fire when ready, gunner. The fundamental problem with Armor-Piercing Discarding Sabot is you get one shot before enemy forces see your position. The Firefly sits hull down, concealed behind hedgerow cover. Ekins places his crosshairs precisely on the lead Tiger's frontal plate. 100 millimeters of hardened steel protection, but the tungsten core does not care about thickness measurements. Only angle of impact matters for penetration. The Tiger advances directly toward his position, perfect geometry for maximum effectiveness. Squeeze trigger smoothly. The world explodes violently. Muzzle blast slaps his face through the gun sight padding. The hedge in front erupts into flame instantly. Dust and propellant smoke blind everything temporarily. Ekins cannot see fall of shot. The armor-piercing discarding sabot penetrator leaves no visible trace if it misses the target. He relies completely on Commander Gordon, observing from outside the turret with head exposed, despite sniper risk. Binoculars raised. Direct hit confirmed. He is burning. The Tiger slews sideways violently. Smoke pours from engine deck compartment. Internal ammunition detonation occurs. Bright orange flash visible through driver's vision port. 3 seconds elapse from impact to catastrophic kill achieved. The physics of armor-piercing discarding sabot penetration operates on principles most tankers never learned during training. When a conventional armor-piercing round strikes steel plate, penetration depends on projectile diameter, velocity at impact, and material hardness ratings. Beyond 850 meters per second, steel projectiles shatter on impact completely. The crystalline structure cannot absorb shock loading occurring that rapidly. This velocity ceiling limited conventional anti-tank rounds regardless of gun size employed. Tungsten carbide changed everything about penetration calculations. Hardness measures 9 on Mohs mineral scale versus 4.5 for steel. Density measures 15.6 grams per cubic centimeter versus 7.85 for steel. Impact tolerance survives velocities exceeding 1,200 meters per second without fracturing into fragments. The 17-pounder armor-piercing discarding sabot round used a 37mm tungsten core weighing 3.5 kilograms encased in aluminum carrier, bringing total pre-separation weight to 7.7 kilograms. Ballistics became counterintuitive compared to conventional rounds. The lightweight carrier accelerated faster through the barrel than full-caliber projectiles. Peak acceleration measured 100,000 times normal gravity. Muzzle velocity reached 1,204 meters per second. After carrier separation occurred, the tungsten core maintained velocity efficiently due to sectional density advantages, meaning lower drag coefficient. At 1,000-yard distance, the armor-piercing discarding sabot core still traveled at 1,090 meters per second. Penetration mechanics operated through hydrodynamic flow principles. At impact velocities exceeding 1,000 meters per second, both projectile and target behave like fluid materials. The tungsten core does not dig through armor mechanically. It flows through in semi-liquid state, displacing steel molecules sideways. Penetration depth correlates directly with projectile length and density measurements. The armor-piercing discarding sabot core, despite 37 mm diameter, could defeat 256 mm of rolled homogeneous armor at 500-meter range, more than twice its own diameter. British production ramped ammunition manufacturing throughout late 1944, but the solution had arrived late enough that thousands of Allied tankers died in Sherman tanks that could not penetrate Panther armor frontally during earlier combat operations. Early enough, however, that those who survived gained a genuine fighting chance in subsequent engagements. The ammunition's post-war influence proved far more significant than its wartime battlefield impact. Modern tank guns, including the American M256, British L-30, and German Rheinmetall 120mm all-fire, direct descendants of wartime armor-piercing discarding sabot principles. Modern armor-piercing fin, stabilized discarding sabot rounds, use fin stabilization instead of spin stabilization, achieving velocities exceeding 1,700 meters per second. But the core concept of wrapping a dense penetrator in disposable carrier remains unchanged from Permutter and Coppock's development work conducted between 1941 and 44. The Sherman Firefly, armed with 17-pounder gun and armor-piercing, discarding sabot ammunition, represented late-war British tank design philosophy perfectly. Maximize what you currently have rather than waiting for what you wish you possessed. Approximately 2,100 Fireflies served throughout Northwest Europe campaigns. Combined with towed 17-pounder anti-tank guns, they engaged German armor at previously impossible engagement ranges. Statistics demonstrate Fireflies achieved disproportionate kill ratios compared to their numbers, representing only 20% of British tank strength, yet accounting for over 50% of German tank kills in Normandy operations. The tungsten dart that punched through at 3,950 feet per second proved that ingenuity applied with precision under desperate circumstances could defeat superior enemy technology decisively. Sometimes, the simple solution involving a mechanism that separates after 30 feet of flight changes everything about warfare. Every event, number, and name in this documentary has been verified through historical records or documented sources.